Hello, my name is Blake. I'm also known as Zoid, and in this video, I want to go over my tool Pathbuster and how we can use that to exploit one of the Pentester Lab exercises on path normalization. Before we do all that, I want to explain a bit about path normalization in this simple sketch or this simple text file here with some information about it. So suppose we have like an internal Tomcat instance on localhost 8081. Now this isn't publicly accessible. We can't access this website, this internal website. Uh, and then we also have a public web app that's called demo.com, and the /home is the landing page. Now, typically how we would test this is we'd just start traversing directories. Now, think of this as the same thing as traversing a file system like in Linux or Unix. Or think of it as similar to LFI, local file inclusion, except we're not traversing files, we're traversing routes or directories. Not directories in the file system, like routes from a website or something. Now, if we traverse two directories back, as you can see here, there's one directory here. There's the home directory or the route. We can traverse back two times, and you can see here we'll end up below the web root, below the internal web root. We're too far back, so this will typically result in a 400, sometimes 500. Just remember, like status codes can be misleading, so don't always rely on that. Now, if we go forward, we arrive at the web root. But as you can see here, we've specified some arbitrary string, just a random characters. And then right here, this would typically be like a 404 because the route doesn't exist. But then if we start brute forcing here, like using fuff, do a search, and we do some directory brute forcing, and we might stumble across this manager HTML that results in like a 200. Because the reason why it results in 200 is because we've accessed it from the web root, and that's where the path is located. So we get access to it. In the wild, I haven't really stumbled across a path normalization vulnerability that accesses Tomcat instance that does not give me a 403. I have stumbled across a lot of path normalization vulnerabilities that allows me to access manager HTML, but I'm always presented with a 403. Sometimes the example page is like listed, and you can access the examples page, but they just have a couple of like example servlets. It's not really interesting. Okay, so let's utilize this method with our tool, with my tool Pathbuster, and we're going to be using it against this Pentester Lab exercise. So this Pentester Lab exercise, it tells us pretty much what to do here. So if we go to Pentester Lab directory here, it says time to ask nicely. So this is a public public route. Now, if we go ahead and just try and use this traversal here, you will notice that the browser does normalization. Whoops. And it goes back to that same directory. So it says time to ask nicely because browser does do path normalization as well. So we would have to use like curl and use the path as is to ignore path normalization so we could access this internal route, Pentester Lab. Or we could use a tool like Pathbuster, which I've designed, which does what we need it to do. So the first thing would be to like crawl this website here and collect a whole bunch of like routes. And then we'll need the payloads file containing all the traversals. And then we'd need the tech file containing all like the potential internal routes. Now I've gone ahead and created those files, and I've gone ahead and installed Pathbuster. If you want to learn how to install that, you can just go to my GitHub repository, and it tells you how to install it. You first install Rust, and then use cargo install Pathbuster to install Pathbuster. And there's also some some basic examples and the usage or the arguments here as well. So the payload would, the command would kind of look like this. So we type the command, and then we type in tacu, specify the URL. And we have to make sure we specify our path replacements here. So we've got this paths replacement here will contain the list of paths. For instance, in our list of paths, we've got these ones. We just got uh, uh, sorry, we've got I've just typed in the wrong command. The tech should go here. Yeah, so tech.txt should go there. And then no, sorry, no, that was the right command. Sorry, my bad. Sorry, I've just gotten all confused. So, in the so in the paths file, this would be the list of paths for when you crawl, or like from when you're crawling. So all like the crawled paths. And then the payloads file will contain like the traversal payloads. The payloads placeholder, sorry, will contain the payloads, the traversal payloads. That's for the payloads replacement. And then the words replacement will contain a list of like the potential internal routes. So here I've just got some basic ones here. So if we go ahead and run this, and also the deviation is like how dispersed the responses are. So it uses an algorithm that will detect the distance between two strings, and we use this to compare the route that we've discovered from the so we use it to like compare the distance between the public web root response and the internal web root response. So say we found for instance in this example here, we accessed the internal Tomcat manager. So we'd compare this response here to and we'd like to compare it to the web root one as well. So we check to see if they're different. If they're different, then we print out a valid finding, because they need to be completely different. Because if we try and access the manager HTML, like the Tomcat manager in the web root, if that's accessible, then it's pretty much just an unauthenticated web endpoint. It's not a pathomization vulnerability. But if we compare this, and this gives us like a 404, or doesn't allow us to access it, to this, and this gives us like a 200, and the responses are different, then we've got some valid finding. So let's go ahead and run this now. And you'll find that it's got to go ahead, generate some payloads. It actually generates some additional payloads using like the whole entire ASCII table, year encoded ASCII values. It generates that. You'll find that here, hopefully, it finds the vulnerability. I've noticed sometimes, in this case, I've noticed sometimes I need to decrease the amount of concurrency, and sometimes I need to decrease the rate limit, the in-flight request per second, because that can like kind of overload the server a bit. So let's just lower those values. Sometimes you need to play around with these. You're going to make sure you don't get rate limited as well, because by default, it sends 1,000 requests per second, which is a bit overkill. So you're going to make sure you lower that, and make sure that your concurrency isn't too high as well. So hopefully this finds it. May have to run it again if it doesn't find it. Looks like I might have to. It worked. The funny thing is, it worked before, so it must just be that it's overloaded at the moment. Let's actually have a look to see if I haven't like overloaded the server, or if it hasn't like timed out. Yeah, I think let's just change both to 5 and see what happens. Nah, let's just try and do that maybe. Oops. It actually could be that the deviation is too high, because you'll find that it's because the deviation was too high. So you'll find that like this is a valid finding. You'll find that if this would actually be a valid finding, we can't just, like I said, we can't just access in the browser, because the browser does normalization and it won't work. The browser does normalization for dot slashes, other sorts of payloads that won't normalize. But if we do a curl path as is to ignore path normalization, you'll see that we get like the flag here. Now, if we compared that, now, like since we had to make the deviation 0, or it could probably work with 1, that's because if we compare this to the like the public route, it's not so different. Like, yes, it is different, but it's not so different because it's text. It's a little bit different. You know what I mean? So if it was, excuse me, if it was like a massive response that like produced a flow for, and then just some basic JSON in the internal route, then it would probably be a deviation of like 3 or 4. But this would probably work with like deviation of 1. If it doesn't, then it might just be that the value is 0. Looks like that the value is 0. So you need to make sure that for the deviation, if you leave it at 0, it's going to check to see if it's greater than 0. So you could pretty much leave it at 0, but then you're not detecting big changes. You're only detecting. Oh no, you could actually leave it at standard deviation of 0, but remember that's going to be 1, 2, and anything above. So you might find that not standard deviation. Oh God, the deviation of 1 might um, detect like something not so different. So in our case, we just had to put 0, but you know what I mean. I'm kind of rambling on about it a bit, but yeah, that's pretty much how the tool works. And yeah, I hope you enjoyed this video. Let me know how I went and what could be changed with my tool, and I hope you enjoyed. Hope you find some cool bugs.